Alright guys, welcome back to Underground Science, and in this video we'll be talking about alpha decay. Alright, and in my previous videos, in particular the beta positive decay and beta negative decay videos that I made, right, positron emission and beta negative decay, we said that those were forms of radioactive decay, right, that an element underwent or an atom underwent to become more stable. And just like that, alpha decay is going to be a topic of this video. And alpha decay is also a form of radioactive decay where the nucleus of an atom, it will emit a helium-4 particle. All right, and a helium-4 particle, in this notation, you can see that the helium-4 particle will have a mass number, right? The mass of the nucleons of the nucleus of helium-4 is 4, right? So that's the mass number, which we denote as A. And then we can see that the number of protons helium has, or helium-4 has, well, helium also is 2, and 2 is also denoted as, or not 2, but the atomic number is also denoted as Z. And the atomic number is also the number of protons and electrons an atom has. Well, electrons, it's the number of electrons an atom has, only if that atom is neutral. Okay, so if that atom doesn't have a formal charge, then the atomic number is also the number of electrons that atom has. All right, so in this case, helium-4 is neutral, so it also has 2 electrons. But remember, electrons aren't part of the nucleons, because remember, the nucleons make up the protons, and the neutrons of a nucleus of an atom. So electrons orbit around the nucleus, if you guys remember, right? It's not in the nucleus. Unlike nucleons, they're in the nucleus. Okay, and in a helium-4, if an atom emits a helium-4 particle, what's going to happen is that atom is going to lose 2 protons and 2 neutrons from its nucleus. And the reason for that is because if, let's say I'm letting go a helium-4 particle, right? And a helium-4 particle has 2 protons and 2 neutrons, like we said before. If I'm letting a helium-4 particle go, I just said that I'm letting go of 2 protons and 2 neutrons. So same thing, if an atom undergoes alpha decay, it's emitting a helium-4 particle from its nucleus. So in alpha decay, where that atom is losing 2 protons and 2 neutrons to become more stable. Okay, so now that we know that, let's go ahead and see 2 examples in this video that involve alpha decay. Alright, so let's start off with uranium-238. Alright, so let's go ahead and write that down. We have a periodic table here to help us for reference. So uranium-238, and if you go to the periodic table and look at its atomic number, which is right here, is 92. Alright, and we can already tell that this atom has a lot of protons. Alright, it's greater than 83. So it's going to undergo radioactive decay, and in this case, alpha decay, all right, because it has a lot of protons in its nucleus. So what's going to happen is that uranium-238 is like, yo, I need to become more stable, so, I'm going to undergo alpha decay. All right, so alpha decay, and remember, all alpha decay is all we're doing is we're just emitting a helium-4 particle. Okay, so what's going to happen is we're going to have the emission of a helium-4 particle, and what that's going to do is, if we're letting go of 2 protons and 2 neutrons here, we're going to have an atom now that does not have 92 protons anymore, right? Because we just lost 2 protons because of this ejection of the helium-4 particle. Now we're going to have an atom that has 90 protons, and because our mass number, we just let go a mass number of 4, right? So it's not going to be 238 anymore. We're going to have an atom that has a mass number of 234. Okay, because we let go of 2 protons and 2 neutrons. So altogether, our mass number decreases by 4. All right, so we'll just put a -4 here. And we're also going to put a -2 here for showing that we lost 2 protons. So -2 protons and -4, we'll just say atomic mass here. All right, atomic mass units, or let's just say atomic mass. All right, actually, no, not atomic mass, just to be more specific, just to be more consistent, because we've been saying that the top number is the mass number. So we'll say we have a -4 decrease in the mass number. All right, so that's going to be more consistent. Okay, now that we've written that, all we have to do now is just go to the periodic table and see what element has an atomic number of 90. And we see that that element is thorium, okay, which is right there. And thorium is written as TH, as you can see in the periodic table, right? So thorium, TH. All right, now we can see the full reaction, okay? So uranium-238, the nucleus of uranium-238 let go of an alpha particle. All right, so again, this is also called an alpha particle, which is the same exact thing as a helium-4 particle. So the nucleus let go of a helium-4 particle and it became thorium-234, which is an isotope of thorium, okay? And so what happened was, again, we lost 2 protons and we lost 2 neutrons. So I didn't write that down. So let's write that down. So after alpha decay, we lost 2 protons, which we just said right here, all right? And we're also going to say that we lost, let's choose red, all right, we lost 2 neutrons. And we know we lost 2 neutrons because, remember, we're ejecting a helium-4 particle. And how many neutrons does helium-4 have, right? 4 minus 2, remember? In our previous videos, we said to calculate the number of neutrons, you do the mass number minus the atomic number. So 4 minus 2 is 2 neutrons. So we lost 2 neutrons, and we also lost 2 protons because helium-4 has an atomic number of 2. All right. So that was the first example of alpha decay, and let's look at another example of alpha decay. I can't speak. Okay. So our next and last example for this video, right, we don't want to make it too long, and to just get the concept down, is going to be, we're going to work with bismuth, all right? So in particular, we'll work with bismuth 209, all right? So let's go ahead and write that down. So bismuth is actually denoted as, choose a different color, Bi. No, that's too close. You have to use we have to write down the mass number. So there you go, Bi. And the particular isotope that we'll be working with is going to be bismuth 209. All right, and just for reference, let's go use our periodic table to see what the atomic number of bismuth is. All right, so let's go find bismuth, and there it is right here. All right, so again right here, and we see that bismuth has 83 protons, or the atomic number is 83, same thing, okay? So bismuth with 83 protons, go and write that down. All right, so 83 protons, and because it has a lot of protons in its nucleus, in this case, we'll be seeing what happens to bismuth 209 when it undergoes alpha decay, okay, a form of radioactive decay. Again, radioactive decay, an atom undergoes radioactive decay just to become more stable. All right, so the nucleus needs to become more stable, which is why the nucleus emits a helium-4 particle in alpha decay, so it can lose 2 neutrons and lose 2 protons and have a better neutron to proton ratio, resulting in more stability. Okay. All right, so let's say, let's label our arrow that what we're doing is alpha decay. All right, so bismuth 209 is unstable, so it's going to undergo alpha decay, and you guys probably already guessed what I'm going to write next is that the nucleus of bismuth 209 ejects a helium-4 particle, okay? And again, as we said in previous videos, that, let me just trace this over, that the 4 is the mass number, which is the mass of the nucleons of an atom, so the protons and the neutrons, and the bottom number represents the atomic number, or the number of protons in that nucleus of the atom, all right, and the electrons, but we're just focusing on the nucleus of atoms in this type of decay, okay? All right, so helium-4, and so what's going to happen now is that, again, helium-4 has 2 neutrons and 2 protons, and we just ejected that out of the nucleus of bismuth 209. So we lost 2 protons and 2 neutrons. So we're going to have an atom that we decayed into that's not going to have 83 protons anymore. Again, why? Because we just lost 2 protons, right? Because helium-4 has 2 protons. We're going to have an atom that has 81 protons. Okay, and again, we just lost a mass number of about 4, right? So we're going to have an atom that has a mass number of 205, okay, because we lost 2 protons and 2 neutrons. So our mass number decreased by 4. All right, and so now all we have to do is go to the periodic table and see which element has 81 protons. So let's go ahead and go do that. All right, so we're right here, right? Bismuth, and then bismuth alpha decayed, bismuth 209 did, and resulted in 81 protons, which we can see is thallium. All right, so thallium 205 is what we alpha decayed into, right? When we started off as bismuth 209. So thallium 205, let's go ahead and write that down. Thallium 205. All right, so I hope you guys saw that all alpha decay is the ejection of a helium-4 particle from the nucleus of an atom to become more stable, right? So again, we can even see in here that we went from 83 protons to 81 protons, right? Because we ejected a helium-4 particle which had 2 protons. So if we're giving away a helium-4 particle, we're pretty much giving away 2 protons and 2 neutrons. So that's why we lost 2 protons. And then you guys can see that, you know what, let's just go ahead and calculate it, all right? So mass number minus the atomic number. So that gives us the number of neutrons bismuth 209 has. So 209 minus 83 is going to be 126, okay? So what does that mean? Bismuth 209 has 126 neutrons in its nucleus, okay? And let's go ahead and calculate the number of neutrons thallium 205 has. So again, the same thing, guys. We're going to do the mass number minus the atomic number to find the number of neutrons. Almost said protons there, but that's not right. All right, so mass number minus the atomic number, so 205 minus 81, and we get 124 neutrons. All right, so we got 124 neutrons. All right, so as you guys can see, what happened is that a helium-4 particle had 2 protons and 2 neutrons, but bismuth 209 ejected that out of its nucleus. It gave it away. It's like, all right, I don't need this anymore, right? I need to become more stable. So because of that, we lost 2 protons, and as you guys can see now that we just calculated, we lost 2 neutrons, right? We went from 126 neutrons in its nucleus, and now we have 124 neutrons in the thallium 205 nucleus. So we decayed from bismuth 209 to thallium 205, and we just got more stable. All right, so that's the basic idea of alpha decay. We're emitting an alpha particle, or also known as a helium-4 particle. All right, and that's going to result in the nucleus of that atom that's undergoing radioactive decay, or alpha decay in this case, to become more stable. And that's it. That's what alpha decay is. And hopefully, I'll see you guys in my next videos and my future videos that I'll be making about more cool topics in chemistry, like quantum numbers and electron configurations. And also I'll be making videos about or topics in biology, biochem, and physics. All right, so I really hope to see you guys there, and don't forget to hit that notification bell so you know when I publish my videos, and don't forget to subscribe and like. All right, see you guys next time.